All right, folks, we up on the inside there. Up and running. Nah. Back into across here now. Pull up my road. Oh, it's Leon. Yeah, I think it's 4 pages each. From the three of them and an extra one. Should have? Yeah. It's 96 pages for a study guide. Oh, wow. Okay. The whole syllabus.
I'm not complaining. No, that was wrong answer to do. Yeah.
There's
like
integrated maths, but that's still not
yeah.
like regular maths. It's a little above. That's correct.
Yeah, pretty much. So applied is like these statistics.
I don't
and
know
probability
if Trinidad does it.
Pure math is like trigonometry.
Show up top Oreos. My phone, is teeth in my head. No. I just said tomorrow. It put top Oreos. Top no Oreos. Oh, proofs. Proof by induction, yeah. Well, we never did that.
Really?
Yeah, that wasn't on our syllabus.
I did that with Kirk.
Yeah.
I thought that was so fun. Wait, that's kind of cool.
Proof by induction. Yeah, that's a similar. All right. Yo, why did you do that? Yep. No comment. No. And if it's your all your maths exam is pretty soon, or what's going on? Because neither Jolie nor Khalifa are here. All right, so folks, let's take a start. It's almost 6:45, and I wanna finish off this paper today so we can start a new one on Wednesday. All right. Hold that for now. That's the last question then. Follow D'Angelo here. Hey, evening, D'Angelo. All right, so everybody has question. Well, I did the paper question 9, right? Okay, cool. So let's take a read. So of course, question 9 has both circle geometry and trigonometry. All right. Okay. So as per usual, let's take a read of the question and see what's going on here, and then see what rules we could apply on these things, right? So K, L, M, and N are points on the circumference of a circle with center O. Right? So let's take a look. So K, L, M, and N are points on the circumference with center O. All right. XY is a tangent to the circle at K. So XY is this line across here, right? And a tangent is a straight line that touches a circle at one point. Okay. And then they said angle LKY. So LKY is 48 degrees. So they put that there. MKO. So MKO is 12 degrees. And XKN is 56. XKN is 56. Okay, cool. Let's see what they want us to find. Now, clearly we have to find the value of angle KOL, giving the reasons for each type of it. So KOL KOL. So we're going to find this angle here. All right. Okay. So let me just see if I could actually draw the arc correctly. Hey, Vivek. Right. So this angle here. Right. Let me scroll down a little bit. Okay, so it's just that question on this page. On the next page, what we got to find? Oh, we have 4 more angles after that. Okay, so hold on. And for these ones, just find the value, and it's 1 mark each. So those ones will be a little easier because it'll be a little less intensive in terms of what we got to write. But we'll still identify the rules as we go along. We'll talk through them. All right, so yeah, Vivek, good to see you. All right. Okay. So I'll give you a minute, see what you can come up with, and then we will talk through. All right. Of course, if anybody has any questions, any suggestions, let me know. You're not under exam conditions, right? All right, cool. Okay, so to me, they want us to find that angle. Now that is the angle of the center. Now, if we had a line from here to here, we could use the angle of the center is double the angle of circumference. We don't have that line. Oh, sorry, yeah. All right, now check it. O is the what? What is O in the context of the diagram? Center of the circle. Now we have a couple of lines coming out from O, do we not? We have this line here. Hold on, let me see if I get a slightly heavier weight on the pen point. Right, we have this line here, which is OK, and we have this other line, which is OL. Now, both of those lines start at the center of the circle and go straight to the circumference. What do you call that type of line again? It's a radius. And in a circle, all radii are the same one, the same length. Now, if we were to, let me just use a slightly different color here. This is a blue, right? If we were to close up this triangle, right? And let me actually block off this line here. If we were to close up that triangle, right? What kind of triangle would it be? Isosceles, right? Which means, so what is the same in an isosceles triangle? The 2 base angles, right? So this angle here equal. And of course, the 2 lengths opposite the 2 equal angles, right? Okay, so if we were able to find one of those base angles, we could find the other one. And then, of course, what's the sum of all the angles in a triangle? 180. So we could add those 2 together, or just multiply it by 2, and then subtract from 180. So the question now becomes, can we now find one of the angles inside of there? Now, what angles do we have? We have a 56, we have a 48, and each of those angles is an angle between, hold on, let me get a kind of orange going on here, right? Yeah. So this line XY, what do you call that line again? The tangent. Now the angle between tangent and radius is 90 degrees. 1 second, sorry. All right, so that whole thing there is 90. And don't we have a piece on the outside here? That's 48, not so? Okay, so if that's 48, the blue piece on the inside, how you would find that? Subtract 48 from 90. Yes. All right. So, sorry, I want it in the blue. Yeah, my bad. Right, now that angle, by the way, is angle OKL. So OKL is equal to OLK. All right, so let's make some notes here, right? So because OK, as in the magnitude, is equal to OL, right? This implies that triangle, sorry, one sec. I could fix that. That triangle OKL is isosceles. Whoop, my bad. Isosceles, right? So we're okay with that piece there, right? So because those are two radii in the same circle, all right? Now we also know, right, that the whole angle, so OKY, so the whole angle between radius and tangent is 90 degrees, right? So OKY, which is angle OKY, is equal to 90 degrees, and the reason is because angle between radius and tangent. Give me one sec. Let me just check. Okay. Hey, YouTube advice. Yeah. Right. And from there, we could say, right, that angle OKL, right, which is the blue, this blue angle here, angle OKL is therefore equal to 90 degrees minus the 48 degrees, which is 42 degrees. With me so far? All right, cool. And we know that OKL is equal to OLK, as in the angles, as in this blue angle here and this blue angle here, right? Because triangle OKL is isosceles. Therefore, angle KOL will be equal to 180 minus, you can either put 42 by 2 or 42 plus 42. That's 84, which makes the angle at center 96 degrees, right? And don't forget, you also want to state that, right? The angles in a triangle, the interior angles in a triangle sum to 180 degrees, so they add up to 180 degrees. Yo. You could put it back if you want, but it doesn't really help what we're doing right now. It will come into play in the other question, but I wanted to remove it so that it wouldn't, as I like to say, clutter up the visual space. Right? The interior angles of a triangle sum to 180 degrees. No matter. Yeah, if you left it 12 in, take it out. No matter, because it had no bearing on how we did the work. All right. Okay, Google Meet. So Aisha, D'Angelo, Donovan, Juliana, Hanifa, and Liam. If you guys are good with that, kindly give me a G in the chat. Please and thanks. If you need me to re-explain any particular aspect, right? If there's anything specific you want to go over, let me know, right? I'm happy to do so. Okay. And in class, people, are we okay with that one? Yep. All right. Lovely. Okay. Now we have some more angles to find. So what I'm going to do, I'm going to copy and paste this page, but I'm going to just erase all the extra stuff. Erase all that stuff real quick. Sorry. Okay. I think I'll take all these colors too because they're gonna ask us to find some stuff, so I'm gonna put those in colors as well. Right. So they want LMN. So LMN. Let's take a look and see where LMN is. LMN. Come on, man. Philip Davis said, right? That's this angle here, right? That's LMN. You could call it A because that's if you want, right? And angle B is KLO, right? Let's put that one in green now. Right, so KLO. Did we find that one just now? Yeah, okay. So maybe there was another way to find that angle there. I wonder, boy. Hmm. 34. That's on the outside. I don't see how that helping. Anyhow, all right, cool. Then we have MLK. We put MLK in blue. MLK. So MLK is actually this entire angle here. Right, so that's angle C. Oh, I forgot to label the green one angle B. Right, and then orange is the last one. That's I think it was KNM, sorry, KNM. Right, so KNM is this angle here, and that's angle D. All right, okay, so I'll give you guys a couple of minutes because I know some of you all want to try the question, not just see it done. Of course, if anybody has any questions, if you get stuck, if you're not sure what to do, how to do it, let me know. All right, but it'll take a minute. Try a thing. Which angle are we finding? We're finding all A, B, C, and D. Are we going with the pink one first, then the green, then the blue, then the orange. Gosh, yeah, circle theorem here is a real nice topic. Vladimir doesn't like to see that. Wait, the angle is here. What am I talking about? Oops. Is here. Oh, thank you for following. I'm gonna have to do four separate diagrams with this boy.
Yeah.
1, 2, 3, 4. Okay, cool.
Yeah.
Right. I'll give you about a minute and a half again. Now, of course, if you want more time, it's not a problem.
You know how you have the rule where
Mhm.
angle at the center is double the angle is
Mhm.
Can you do that with this and this?
Yes. Sorry, you are correct. That's MLK. Cupcakes, I'm fine. How are you doing? A little tired. have a long night, depending on some factors. We'll see how it goes. Good. I'm glad to hear that. He's a bit confusing.
Yeah, just give me a second.
Uh-huh.
It's for the first one it says angle LMN.
All right, ML.
LMK.
Oh, okay. Thanks for LMK letting me know. So it's LMN.
Yeah.
Wow. How do I do that, boy? All right. Wow. Okay. Right. So yeah, you see why it's important to read? All right. So LMN. Put back some stuff there. LMN is this whole thing. Okay. Actually, let's take down the rest of it. Right. Okay, so if it was this one here, now we so you have a couple ways to look at this, right? This line here is a chord. This is a tangent. And the angle between tangent and chord is equal to the angle in the alternate segment. So that would have been 48 there. Alternatively, we just found that this was 96. And the angle at center is double the angle at circumference, which means this angle is half a 96, which is 48. Right? But unfortunately, I made a mistake. So it wasn't that angle. It was this whole angle here. But the thing is, we could actually use what we just did to find this piece here. And we could also use to find this piece across here. Right? Because right? This piece here, as we saw, is equal to 48 degrees. Sorry, one sec. Right? And if you follow the same rule, again, you have a chord here, you have a tangent here, and the angle between tangent and chord is equal to the angle in the alternate segment. So this angle across here is 56. So the total angle, LMN, is 56 plus 48, which is 104. Yeah? You have two reasons, right? So this is a tangent here, and this is a chord, right? If you build a triangle on that chord such that this other point touches the circumference, the angle here is equal to the angle between tangent and chord, right? So that's one reason. The other reason is because we just found in the previous part that this is 96 here, right? So again, if you follow your kind of dead butterfly rule or Spider-Man, what do you call it, right? The angle at the center is double the angle here. So the angle here is half of the angle at center. Yeah. Yeah. Oh, no, that's the other rule. That the angles in the same segment standing on the same arc are equal. No, we still working ABC and D. Well, because this is the angle we want, right? And for that other one to work, you had to kind of join it here like this. Then you would have that shape. But that's not what we're going on here. Yeah, Cash, I put the wrong angle for A. Right? Okay, so that's the 48 there. And again, this angle on this side is 56 because of the same reason. The angle between the tangent and the chord is equal to the angle in the alternate segment. Right? So LMN. Oh, they didn't ask for any rules or anything. They just asked for the value, right? So you can put 56 plus 48, and that's equal to 104, right? Now, in this next one here, we want angle B. Now, we found angle B in the first part of the question because we know that this angle here is 42 degrees, and because this is a radius, and this is a radius, it means that you have an isosceles triangle, and it means that this angle B is also 42 degrees, right? So angle KLO is equal to 42 degrees. All right, in class, people, are we okay with the first two items? All right, okay, Google Meet. If you guys are good with the first two, the 104 and the 42, just give me a quick G. If you need me to re-explain either of them or both of them, let me know. 1, 2, 3, 4. All right, so 2 people are going on. Right. So now we have C and D to go. Okay. Let's take a look here. All right, so that angle C there. Okay, so check it. If you focus on the triangle, right? If you focus on that triangle, we have the two other angles, right? We know this one is 48 from previous. We know this whole angle is 42, right? Which makes this piece here 30 degrees. And if you have two of the angles out of the three, you can add them together and subtract from 180. 30 and 48 is 70, so C has to be equal to 102. All right, so that's 78, and 180 minus 78 is 102 degrees. Right, and the last piece is angle D. Now you have a couple of different ways to find angle D, right? The easiest way to do it actually is to use the solution we just got, because, and I'll show you why, right? Right. And if we kind of blanco the stuff in the middle, right? So are we seeing the cyclic quadrilateral? Right? And what's the rule? The opposite angles of a cyclic quadrilateral are supplementary. What does that mean? It means that if you add them together, you get 180. So D plus 102 is 180 degrees. So, Burkina. Who's Burkina? Danielle. Who Burkina is? All right. Sorry. All right, so all we have to do here is say, okay, well, 180 degrees minus the 102, that's equal to 78 degrees, right? Now, the other way to do that one is again to see. Yeah, 102. Yeah, 102 is correct. I know. Your friends? I don't know. Right. Right. Now, the other way you could do it is to say angle between tangent and chord. Let me explain. Right. So if you and you use this whole angle here, and we know this piece here is 30 degrees, so the whole thing is 78. And the angle between tangent and chord is equal to the angle in the alternate segment. So whether you do it one way or the other, you get the same value. Yeah. Okay, so I think we're okay with that. In class, people, are we okay with C and D? All right, cool. Google Meet, if you guys okay with C and D, kindly give me a quick G in the chat. If you need me to re-explain anything, let me know. Right now is a good time to do so. Oh, that's it. So the next two, let me know. Something, send my message, send my SOS, something. All right. Now we're on to the trigs. All right, let's take a read, and I'll give you a minute. Yeah, a minute or two. Which one are you doing there? B part one?
Yeah.
All right, well, I'm not gonna talk you through them. So let's take a look there, right? Right, so E, F, G, and H are 4 points on a level ground. Diagram below gives information on the distances and angles. Okay, cool. So E, F, G, and H are on the same ground, right? So nothing is up in the air. So I don't think we have any angles of elevation or depression. So, but we have some bearings. So we have showed the value of X is 29.5, correct to 1 decimal place. Hey, Cash. You can see the 3 off. That's all right. Right. So let's catch back. Angle X. So they want to show that this angle is 29.5 degrees. Okay. So what we're going to do is, hold on, sorry. Let's draw in somebody Norwich. Yeah. If they give you what, sorry?
Okay, cool. So we're working from
If it's into the ground. And then draw a right angle triangle. Right? with G as the base and T as the height, right? G to T. And F is also on the ground. So you have to put up like a diagonal. Right? Yeah? Yeah, G is at the base. T is at the top, and F is the other point. Right? And the angle of elevation to T from F is 31. Right? Yeah. I have no idea. I lost all that. So I'll print out something for you, right? Just pull the one which goes, you know. Actually, hold on. I have the PDF open. Give me a sec. Yeah, I cleaned up apparently, and I have no clue where I put everything. And of course, I'll find them when we don't need them. Such is the life. Huh? Okay, just give me a sec. Let's print out something for Khalifa then. Right. So what we have going on here is we have a triangle, the pink one. We have 3 lengths, and we have an unknown angle we have to find. So the only thing we could do in that particular case is either draw it to scale or use cosine rule. Right? So call that H. So this side here will be H. That is G. So this side here will be G. That's F. So this side here will be F. Right. Okay. So normally with cosine rule, we're trying to find a length. Now this is the unknown angle, and that's the length opposite, right? So that's H. So normally we would have started up with H squared is equal to F squared plus G squared minus 2FG by the cosine of angle H. right? Which is the x, right? So let's put cosine x. Well, actually, let's put h for now, right? We put x to replace it in a little bit. Now we're actually trying to find the value of h. So one thing, so you can do it different ways. One, you could substitute the values inside and then transpose to find the angle, or you could transpose first and then substitute. Let's sub first, right? So h, the length h is 6.9. Actually, let's transpose first, because writing all those decimal places multiple times would be annoying. All right, so you're trying to find for that. Right, now you can do this in different ways. So one way is you could carry across the f squared and g squared, right? And subtract f squared and g squared from both sides. So you have h squared minus s squared minus g squared. And that's equal to minus 2fg by cosine h. And now you have to move the minus 2fg, which is attached by multiplication. And how do we remove something attached by multiplication? Division. So we'll have h squared minus f squared minus g squared all over minus 2fg, and that's equal to cosine h. And how do we undo our cosine? We find the cos inverse, right? So therefore, you could say h is equal to the cos inverse of h squared minus f squared minus g squared all over minus 2fg. Right? Now, don't try to plug the whole thing into your calculator unless you know how. Right? What I would suggest you do, work out your numerator, work out your denominator, plug it in, and then after that, plug that answer back into the cos inverse, right? Cos inverse. H is 6.9 squared minus 5.3 squared minus 11 squared all over minus 2 by 5.3 by 11. Right. Because you're dividing by this. And that's the problem with telling children when you carry something across equal sign, change signs. That's not how it works. The reason they change sign is because if something was added on one side, to remove it, you have to do the opposite operation. Correct. Correct. You're multiplying by minus 2fg. So to remove something that's attached by multiplication, use division. Hey Kyle, how are you doing? Thanks for the heart. Right. So let's plug it up into our calculator. So of course I have this old calculator here. 6.9.9. Yeah. Right. So that might, right. And now we divide that by minus 2 by 5.3 by 11. Right. So point that. So it's cos inverse of that. 29.5. All right. Yeah, man, Cabo vibes. So equal to 29.5 degrees. Right. Okay, cool. Right. Apart from that, the only other way I could think to find this is to actually do a scale drawing using centimeters as opposed to meters. Because obviously, if you had meters, then you would not be able to draw it in the exam. But yeah, I wouldn't advise doing that unless you're really comfortable with constructions. All right. Okay. So this once again, we had this pink triangle. We have all of the lengths 5.3, 11, and 6.9, and we have an angle here that is unknown, but we know none of the angles, but that's the one you want to find. So again, if you have all three lengths and no angles, you have, well, basically no choice as far as I'm concerned, but to use cosine rule, right? Now the angle we're looking for is at this vertex h, so that's why I use an h, because the opposite side would be small h. And normally with cosine rule, you're trying to find for a length, so you put that first, the length, h squared. So that's equal to f squared plus g squared minus 2 by f by g by the cosine of h. And then from there, you transpose, you pick apart until you have cosine h or h by itself, and you substitute, simplify, and solve, right? If the transpositions were giving you trouble, let me know. We could talk through it again. All right. Okay, so that's the first piece of the question. The next piece they want, all right, a vertical tower, GT, is constructed at point G. So hold on. At point G, they made a tower going up. right? Now, it's kind of weird because you don't really have any 3D perspective on the graph. But yet, basically, what you're seeing here is on flat ground, and then this tower is being built on top of that. So again, the angle could differ based on your perspective, but there's a vertical tower coming out of the ground at G. Right? Right. And it's pivoted to the ground at points E, F, and H using pieces of wire. So I'm guessing that means that it is attached or tied down to the ground at points E, F, and H using wire. E, F, and H. Right? Okay. No problem. The angle of elevation of the top of the tower, T, from the point F is 31 degrees. Okay. So hold on. We have a point G. We have a tower. Top is T. Oh, some distance off is point F. And they are telling us that the angle of elevation of the top of the tower from F is 31 degrees. And they want to know what is the length of wire to secure point T to point F. So what is the length here? Right, now that is the hypotenuse of the right angle triangle. Oh, at least like that was a little typo on your part. Unless you wanted to jump in and solve the question. Right. Now, if we can't use Pythagoras if we have the two other lengths. And I don't think that we do, because they don't give us the height of the tower. And I think the height is the next piece. Oh no, it's just bearings. Wow. Hey Peter, how are you doing? Good night. Good to see you. Now we have to go back to the question, see what information we do have. Okay, cool. We have the distance from F to G. We have that distance, that's 6.9 meters. Okay, let's go back here and put it at 6.9 meters. Okay, so the length we want is the hypotenuse. It is the length opposite the right angle in the triangle. And relative to the angle, that side across there is opposite, which we neither have nor are looking for, which means by default, the remaining side is the adjacent side. So if you think back to your regular basic trig ratios, sine, cosine, and tangent, which of those three ratios uses adjacent and hypotenuse? If you're outside all day in the sun, you'll get a tan. The opposite of holy is sinful. And if your aunt and her husband make a child, that child is your cousin. The opposite of holy is sin. Right. Okay, so plug it up. So cosine 31 is equal to adjacent over hypotenuse. Right? You can put TF if you prefer. Or if you want to give it a letter like X or Y. Well, you can't use X again because you used X before. So, all right. If you could walk it out there, and then we'll go on. Right after we finish this question, we go into question 10 one time. Question 10 seems relatively short compared to what we normally get, but we'll take a look at it. And we have a last part of the question you need to backtrack and do. Right, let's go. So here we can multiply by the denominator. 6.9, sorry. And now to solve for TF, right? So 6.9 all over cos 31, right? Plug it up. So 6.9 divided by cosine 31, about 8. TF is approximately 8. So you can put 8.05 meters. The 3 significant figures, right? So yeah, so we see that they have explicitly stated on the front of the paper any non-exact answers should be stated to 3 significant figures, and in the case of angles, 2 decimal places, unless otherwise stated. Right? So know your instructions and follow them. All right. Okay. In class, people, are we okay with this particular one here? Any questions? Anybody? Anything? Talk to me now. What's going on? So you're studying it hard there. Kelly for Jazeera, you okay with that? Any questions at all? Sure. Looking like you're sleepy. Ready for your bed. All right, Google Meet. If you guys are good with that item, just give me a quick chat, please and thanks. If you need me to re-explain anything, that's not a problem. Just let me know. Okay. All right, CPU. All right, cool. There we go. Right, now we have 2 pieces down here. The bearing of E from H is 228 degrees. So they want the bearing of H from E, so that's a reversal. And they want the bearing of G from H. All right, so first things first, let's go back to the diagram and draw any bearing. So the bearing of E from H is 228. So you had to go at H and draw the bearing there. All right? Actually, you know what I'll do? Let me copy and paste this page so that we don't have too much stuff on the same page, right? We'll erase all the extra stuff there. Hold on, I could do this a faster way. Right. Okay. So the bearing of E from H, right? So E, hold on, sorry, my bad. The bearing of Beavis. Right. So the bearing of E from H is the clockwise angle starting from the north line at H and go until it hits this point here. The line connecting the 2 points, right? So it's that pink angle there. Now, if you look, we actually have pieces of it. We have the 29.5 degree portion. We have a 54 degree portion, right? So this whole angle is 228. And we could find this piece here because we could add 29.5 and 54. Well, hold on. I kind of getting ahead of myself. Sorry. Right? Now, the first thing they want is the bearing of H from E. The bearing of H from E is this clockwise angle here. Yo. Huh? How I get what? 228? That's the question told us. Is there a new paper? Right. Well, right. So this angle here is what they want. That's the bearing they want. They want the bearing of H from E. Now, how do we see to do this? We saw that what we could do is we could extend the line joining the 2 points. Oops, sorry. And when we do so, right, we cut that angle, we cut the bearing into 2 pieces, right? The piece, hold on, I'm trying to figure out what color. All right, I'll do a darker green on that, right? Right? The piece on the outside here is the angle on a straight line. And what is the angle on a straight line? 180 degrees, right? And therefore, we can find the smaller piece here. And again, all north lines are parallel. And you have a line cutting through them, which gives rise to what? F and Z angles. So this angle here, let's just call it theta, and this angle here are equal, right? So if we use 228 minus 180 to find this piece here, we automatically find that piece down there. All right, so let's do that. All right, so that's 228 degrees minus 180 degrees, that's equal to 48 degrees, right? I'm going to recap it one more time in case you missed it the first time, right? Okay, so what they want, what they gave us in the first place is the bearing of E from H. That is this angle here, and that is 228 degrees. Now, what they want us to find is the bearing of H from E. So the bearing starts at the north line and goes clockwise until it hits the line joining the 2 points. All right? Now, to facilitate this, we're going to extend the line joining the 2 points. Behave yourself, behave yourself. All right, you could go away. What we will do, all right, so you extend the line such that it cuts that initial pink bearing into 2 pieces. It cuts it into a 180 degree portion because that's the angle on a straight line, and then it cuts it, and then of course the remainder here we can find, and that remainder there will correspond to the bearing down here, because again you have 2 parallel lines and you have the blue line cutting them, and that gives rise to F and Z angles. In this case we have F angles, right? So that angle there is simply 228, the whole pink angle minus the blue, which is 180 the angle on a straight line, and that's equal to 48 degrees. Yeah. Right. So okay. So like if you think about north, south, east, and west, right? If the bearing they give you at the start, right? When that, so okay, so let's say the bearing of if they give you the first bearing and it's less than 180, you add 180 to it. If they give you the first bearing is more than 180, you subtract 180 from it. Long story short. Yeah, that's the reversal, right? So if initially, when you got the bearing, the point was out to the east, and you want to go backwards, right? You just add 180, right? If initially the bearing was out to the west and you want to go back east, you minus 180, right? So it's like, for example, if you went east, you'll just continue 180. But if you went to the west first, you want to go backwards, right? Right, so the bearing of H from E is 48 degrees. And now the last thing they want is they want the bearing of G from H. And that's also 1 mark, so it can't be too much work. So they want the bearing of G from H. So G is here. Okay, let me copy and paste the same page again. We could take out some of the stuff there. You know what, I keep forgetting I could just lasso it and deleted. Right, cool. Okay, the bearing of G from H. G from H means you want this angle here. Okay. So how are we going to find that now? Now, we know this piece here is 29.5, right? But we also know that the sum of the angles at that point is what? 180 degrees. So if we found this whole angle here, and subtract it from 360. Sorry, what did I say 180 or 360? Okay, no, sorry, no, yeah. So my bad. The sum of the angles at that point. So for example, if you take this piece here, and you take X, and you take 54, and you remain on the outside, if you add up all those angles, you get 360, right? If what we want is this blue angle here, if we take the orange angle and subtract from 360, we could just find the blue, that's so? Right. Now check this, right? We know that this piece here is already 54. From the previous question, this is 48, not so? And again, this is a straight line, and the angle on a straight line is 180 degrees, which means, therefore, we could find this orange piece on the outside there, which would be 180 minus 40, which is 132. So we could add, actually, we didn't even need to do that. All we had to do is add 180 to 54. Yeah, look at that. Right, so once again, let's recap that, right? So we want the entire blue angle here. right? And we know the sum of the angles at that point is 360. So, sorry, no, yeah, we do need to subtract, yeah. So this piece is 54, and we need this piece inside of here. We know this is 48 from the previous question. So this piece across here would be 180 minus the 40, which is 132. So sorry. So then we'd add the 180 and the 132 and the 54 and subtract that from 180. Well, let me try it again. Let me see again. So they want the bearing of G from H, not so? That's that angle there. Right. Okay, so you said tomorrow it might be a bit late because you have retreat. All right, no problem. We'll be here. Right. So if we were to find the orange, sorry. If we were to find the orange angle, we could subtract that from 360 and we'll find the blue, not so? All right. Now we have a piece of it here already, which is 54, yes? So we need this piece here. Right, now check it. If we again consider extending this line here, this whole angle here would be 180. From the previous part of the question, we know this piece here is 48. From the previous part, right? Right. Oh my God, Chris, I'm a past student. Sage Green, Sage. Then Sage Chan. The only Sage I ever had in my lessons. Yeah, Sage, hey, how you doing? Well, actually, Mishka here. Mishka's teaching with me. Remember Sage from your year? Yeah. Yeah. Yeah, she went HTC Porter when you were at the agency.
Oh.
Yeah. Yes, Sage, good to see you. Thanks for popping on and saying hi. Doing some maths. Right, yeah. So if this piece here is 48 and the whole angle is 180, to find this piece on the other side here, that's 180 minus 48, which is 132. Now we'll take the 132 and the 54 and add them, and we get 186. And to find the blue, we have to subtract that 186 from 360. Right, so 114 will give us that, so 174. Yeah. Oh, the still here too? Also, I'll join you all in the password. Okay. Okay, cool. Fun times. Okay, see you all Wednesday. Later. All right. Okay. So yeah, I'm trying to see if there were any other easier ways to do this. Nothing really popping off, to be honest. If anybody has any suggestions, please feel free to let me know. All right. Okay. So let me see if I could. And that's one mark, eh? G from H, boy. G from H. Yeah, that's that angle there. I feel like somehow we were supposed to find like this piece here and then add that to the 29.5. That's interesting. Okay, cool. Anyhow, let's go from there. Sorry, what? Okay. Right. So if you have steps in your weekend, you can do it in this different way, right? So okay, so like your top, come on, Philip. All right, so your top level would be 360 minus something, right? And that's the 186, right? So it's 360. So we recognize it's 360 minus the whole orange. And then the orange would be something plus the 54. Right? To find that, and to find, is this piece here? That's the purple, sorry, purple, right? is 180 minus the 48. Come on, man, Philip, give yourself. Okay, cool. So 180 degrees minus 48. Right, so that's 132. Right, and then that feeds up into the orange. 54 plus the 132 is equal to 186. And then that feeds up to the blue. 180, sorry, 360 minus the 186 is 174. So this item here, G from H. Ooh. Actually working up possible right now. Okay, paper 2 to be exact. Which year? Right. Okay, yeah. So that one, it was only 1 mark. So again, it makes me think there was possibly an easier way to do this, but it's not popping out to me. So again, if anybody has any suggestions, if you're seeing anything I'm not seeing, please feel free to let me know. All right. Okay, cool. All right. So that's that question 9. So question 9 is done. All right. In class, people, have you any outstanding questions on question 9? Anything given trouble? Want to re-explain, do over, or are we okay? All right. Google Meet. Drill. All right. So I've seen 7 now. So that means somebody pop out. All right. So Aisha, Diane, Lou, Donovan, Juliana, Young Kid, Eugene. So Khalifa gone. All right. Hey, Kenny, how are you doing? Where am I, though? I'm in my class. Right. Yeah, yeah. I just had no one camera is the feed from the other computer. One is the onboard camera, and I had a spare one. So yeah, 2 and 3. Are you on? Are you going on? Right. Yeah. Okay. So I was saying 3 out of 5 people. All right. On to question 10. Okay. I need to print a question 10 for Khalifa. Give me a second. Okay. Cool. Right. So question 10. The question has a vectors in part A, and then part B and C is a matrix. I want to start with the vectors or the matrices? Matrices? All right, cool. All right, so let's start with the matrices. Right, so the matrices P, Q, and R are given below, right? In terms of the scalar constants A, B, and C. 1 second, eh? Right. No, no. Right. Okay. All right, so if P plus Q is R, find the values of A, B, and C. Okay, so I'll give you a minute or two to set that up. Solve for A, B, and C, and then we'll go from there. My aunt wants to know if you are married. I am. Yep, definitely. Yeah. My wife is popping here from time to time, so she see that she might reach through the screen and strangle somebody. He, is that she? Right. So let's set it up. Right. So P plus Q plus R. When we add in matrices, right? So P plus Q is equal to R. I don't know. All right, cool. Who's the no vibes? Right. So you add corresponding elements, right? So you'll have 3 plus minus 1 minus 9 plus b. Oh, sorry. All right. A plus minus 4, which just becomes a minus 4, and 7 plus 1. Right? Now I'll use that to explain, right? 7 plus 1, so the corresponding element there would be 8. And we could agree 7 plus 1 is definitely equal to 8, not so? Right? Now let's stick in the bottom row, right? So a plus minus 4 is equal to minus 4. That's an interesting statement. A minus 4 is equal to minus 4. What's the only number a could possibly be? Check maths. Or add maths. No, you have add maths is a subject under CSEC. 0. 0 is correct, yeah. So if you want to see a working, well, you have to remove the minus 4. To do so, you have to use the opposite operation. So you will add 4 to both sides. And of course, minus 4 plus 4 will give us back 0. All right, so therefore, a is equal to 0. Now, the b, let's go with the green, right? So minus 9 plus b is equal to minus 3. So, long story short, if you quote unquote carry over the minus 9, you have to add 9 to both sides. Yeah, sorry. So b is equal to minus 3 plus 9. So b is equal to 6. All right, and the last one would be c, although they put c first, but all right. Sorry. So 3 plus minus 1 is equal to c. So 3 minus 1 is equal to c. Therefore, c is equal to 2. Simple and straightforward. Kenny, I think you were thinking about like multiplying. Zane said 0. Yeah, that's correct, Zane. All right, cool. Wait, I have 16 people watching. Wow, that's a lot. All right. Yes, I did a counting earlier, actually. 4 and 6. Check back on Wednesday, 4 to 6. More counting. Or check my YouTube channel. Lots of accounting there. Okay. These are backup streams for my class. Yeah, and they stay on my YouTube channel for free for a day or 2, and then I put them away. Okay, are we okay with the first part of the matrices there? If it's too confusing, let me know. Okay. No, there's no problem. All right. Let's see if we can make it a little less confusing. Right, so when you're adding matrices together, we add the corresponding elements. So the top left-hand side, top left-hand side will add the top left-hand side and equal the top left-hand side. Right, so the first one we have is that 3 plus minus 1 is equal to c. 3 plus minus 1 simplifies to 3 minus 1. And what's 3 minus 1? 2. So therefore, 2 is equal to c. Okay, cool. We're going again, right? Top right-hand side plus top right-hand side is equal to top right-hand side. So the next statement will be minus 9 plus b is equal to minus 3. You can rewrite, yeah? Minus 3, yeah? Yeah. Right, so to solve for b, you could add 9 to both sides. Right, so b would be equal to minus 3 plus 9, which is the same as 9 minus 3, so therefore b is equal to 6. Right, and then bottom left-hand side is equal, plus bottom left-hand side is equal to bottom left-hand side. So a plus minus 4 is equal to minus 4. if you drop the brackets, you're just going to get a minus 4. Right, now here, again, if you add 4 to both sides to remove it from the left-hand side, to solve for a, minus 4 plus 4 will be equal to 0. Is that a little better, Khalifa? A little clearer? How are you good at maths, though? Make me mod unks. Make me more moderator. I could. Yeah. How are you good at maths? Plenty practice. And learning from plenty mistakes. Cool. Okay, Google Meet. So people there. So Aisha, D'Angelo, Donovan, Julian, Liam. Are you guys good with what's on the screen currently? Lovely. Okay. All right. So if we scroll, sorry, let's look up here now. All right. All right. So solve the following pair of simultaneous equations using a matrix method. Right. No. Can't make a moderator. Sorry. Just. Yeah. Same one who uncle wanted if I was married. Real fun. Cannabis? You protect the chat. All right, cool. Let me know. Right, I'll see if you need protecting and we'll deal with that then. All right. So do we remember how to? No? Okay. So step 1 is to convert the algebraic equations into matrix form. How do we do that? First matrix is the coefficients of the algebraic terms. Right? Keep hearing people saying algebraic as anyhow. However, I had to stop nitpicking because it's from a person called Al. Yeah, that's the guy's name. Algebra. He had a way longer name, right? Am I cooked? No, you're not cooked. Never do it. I have it on my YouTube channel. Just go on YouTube, look for adapt tuition matrices. I have a whole playlist. I explain this one. Right. So 5. The coefficient here is minus 2. And the bottom row we have 2 and 3. Right? Right. In the next matrix, you put your algebraic terms, x and y. And in your third matrix, you put your solutions, 44 and 10. Okay, cool. Now, my next step is I like to label my matrices. 2 and 2 and 2. Yep, that's correct. Very good. Your girl. So you have matrix A, then multiplied by matrix X is equal to matrix B. Long story short, to solve for X, what we have to do is multiply A inverse by B. So the question now becomes, how do we find A inverse? Right. Well, okay. So A inverse is equal to 1 over the determinant of A, then multiplied by A adjoint. Anybody remember how to find a determinant? See, you multiply these two elements together, 5 by 3. You multiply these two elements together, so 2 by minus 2, and you subtract. And then the adjoint, you swap the positions of the 3 and the 5, and you change the signs along the other one, right? So you have minus 2 down here and 2. Right? Please note, these items didn't swap position like the 5 and the 3. It's just that this was positive and became negative, and this was negative and became positive. So 5 by 3 is 15, and then 2 by minus 2 is what? Minus 4. But when you minus and minus, it becomes a plus. Extremely quickly, yeah. Right. 15 plus 4 is 19, right? So I like to leave them in this form. I don't like to put the scalar, the fraction on the outside. Leave it there, right? It makes for less messy working, a lot slightly easier working. I mean, if you have a calculator that you're using all the time, no problem. Correct, yeah. Yeah, so went somewhere and I saw calculators for sale. Bookstore downstairs, long circular. I think it's RIK, one of them. And there was the Casio, the FX-991EX thing.
That's the one she wanted.
Right. So that one was the one. But it was like $350 for it. And the ones next to were like 120 and 140. Like, so. But it was a class, so it was one too. So that's probably why. So yeah, let's see. All right, anyhow. All right, guys. Now we're gonna come back on this side, and what we're gonna do, right? So xy is just sorry, x is just the matrix xy. So A inverse is 1 over 19, then by 3, 2, sorry, yeah, minus 2, 5, then by 44, 10. 44 on top and 10 below. Right, so again, I like to leave that on the outside of the variance. So now we're going to do row by column. So it's 3 multiplied by 44 plus 2 then multiplied by 10. And then again, row by column. We're going to have minus 2 by 44 plus 5 by 10. Again, keep the fraction on the outside. So 3 by 44 is 132. 2 by 10 is 20. Hold on. 120 and 2 is 132. 2 by 10 is 20. Right. Okay, cool. So that's 152. Okay, right. And minus 2 by 44 is minus 88. And 5 by 10 is 50. Right. I forget one there, boy. Almost at 1/9. That's why I paused it like 1/9. Right. 132 and 20 is 152. Minus 88 plus 50 is minus 38. And now when we multiply the 1/19 by each of them, they kind of each become numerators, and the 19 becomes the denominator. So what is that? 17? Yeah. No, just 7, not 70. Sorry. So you have 7 over minus 2, which implies that x is equal to 7 and y is equal to minus 2. That icon. Yeah. I agree. If you're practicing it, then yeah, it's easy. I agree. All right. Let me scroll up a little bit so you can see everything on that side. Right. So once again, now again, if you need to revise this, like I said, this is one of the few math playlists I actually made videos for back in like 2019. Right? Food. Right. So yeah, so the first step is the ping. Convert from algebraic statements to matrix form. Take the coefficients and make a 2 by 2 matrix as the 5 minus 2, 2, 3. And then take the algebra terms, the variables x and y, make a column matrix, right? And then that's equal to the 44, 10, right? Then I have to label my matrices and show my statement. So A by X is B, so therefore to find X is A inverse by B. Normally I do a few more lines of statements, but I try to kind of summarize tonight. Right, now to find A inverse, you go to the green. So A inverse is 1 over the determinant of A multiplied by A adjoint. The determinant is the product, hold on. Second. Yeah. The determinant is the product of the elements on the first diagonal, going down from left to right, minus the product of the elements on the secondary diagonal, going down from right to left. So that's 5 by 3, which is 15, and then minus 2 by 2, which is minus 4. 15 minus minus 4 becomes 15 plus 4. 15 plus 4 is 19. The adjoint, right, so you're swapping the positions of the 3 and the 5, and these other two, they take the opposite sign to whatever they had initially. So what was positive became negative, and what was negative became positive. Right. And then we simplify and get to this point. Again, you can leave the 1 over 19 on the outside. You could put it on the inside, it's up to you. From the green, we go back to the blue. Right, so now we substitute the actual values in the matrices. They multiply, right, row by column. We simplify, and we get x is equal to 7 and y is equal to minus 2. All right, okay. So Aisha, D'Angelo, Donovan, Julian, if you guys are good with that item, just kind of give me a quick chat, please, and thanks. Right. All right, in class people, did you be okay with that? Jaden, no, talk to me. You okay with that one there? All right. Different Jaziri, talk to me. Any questions, problems, issues? You're good? You sure? Okay. All right. Okay. So now we're going to backtrack into the vectors questions. All right. So I'll give anybody who wants a little minute to check it out first. What FG, EG, and OM. Right. Sorry. Okay. In the diagram below, O is the origin. So they kind of have it on a graph page without having it on a graph page. So O is the origin, right? OE, which is this section here, is 2 times EF. So this OE here is 2 times that there. M is the midpoint of EG. A midpoint cuts a line segment into 2 equal halves, right? So we can make some notes. So we can say that EM plus MG, if you add them together, you get back the whole EG, not so? And we could also say that EM is what fraction of the whole? A half, yeah, because M is the midpoint. And the same could go for MG. MG is equal to a half of the whole, EG. So far, so good? Right. Now, this one here, oh, come on, man, Philip, yourself. Right. So this, hold on. So now they tell us some other information, right? They tell us that OG is given by C. So what it's saying here is that this vector going from O to G, right? That vector is just common C. And the vector OF is just D, right? So OF is D. Nah. Right? Okay. Now, before we go into the requirements, let's dig in a little bit to the blue line. We have some notes in the pink for the pink line, right? Let's talk a little bit about the blue. Now they told us that OE is 2 times EF. So OE is double this distance, right? But when you add OE and EF, we get the full OF. Agreed? All right, cool. But OE is equal to 2 times EF, not so? So if we replace OE with 2 times EF, and then put back the EF from above, right? That's still equal to OF, not so? And what's 2 EF plus 1 EF? 3 EF. And if 3 EF is equal to OF, it means that EF is 1/3 of OF. And if you bring this back now, it means that OE is 2 times this. And what's 2 times 1/3? 2/3. Right. So now with that, let's dig into the question, shall we? So, like I keep telling people, with vectors, all you're really doing is moving from one point to the next along the lines that you have, right? where you have vectors. If you don't have vectors, you can't travel. It's like okay, so like right now, the first one here is FG, not so? Okay. Now, 1 second. Yeah, dark. Actually, yeah. We want to go from F to G. But we do have a vector. See, like how we have the green vector and the blue vector. So we have the C and we have the D. So those are vectors. So we have permission to travel along them roads. We do have permission to travel from F straight to G. But we can go different ways. We can travel an alternative route. If you're at F and you want to go to G, but this road blocked, we could take a different route. What's one route we could take? Correct. We could simply go from F to O and O to G. Right? So FG is equal to FO plus OG. Right? Now we have a vector for OG, not so? OG is the green one. That's C, right? Now we want to go from F to O, but that's traveling in this direction. And that is the opposite direction of the blue vector, not so? Right, so it means we have to invert the vector. All that means, right? So FO is the inverse of OF. Right, so minus OF, right? So OF is D, so minus OF is simply minus D. OG is C, so all you have to do is put minus D plus C or C minus D. Right? So once again, we want to go from point F to point G, but we don't have a vector along that line. So we can't travel there. We have vectors along this line here and that line there. Right? Now this one down here, the horizontal looking one, that's just to go from O to G, right? Sorry. So the first thing we want to find is how do we get from F to G if we can't simply travel along the line connecting them? We have to look for alternative routes. So the easiest one is to go from F to O and then O to G. Right? So put that down. That's your big letters. F to O and O to G. Right? Now OG is simply given by the green vector C. To go from F to O, however, that's going backwards along the blue vector. And to go backwards along a vector, all you have to do is invert the vector. And all that means is putting a minus sign in front of it. So if going from O to F is a positive D, going from F to O is simply a negative D. That's all. All right, I'm going to have to repeat a color. That's okay. All right. Now they want EG, right? So EG is the pink line, right? Do we have a vector along the pink line? No, we don't. 1 second, eh? Let's shift this across a little bit. Right. So we want to go from E to G. Actually, let me copy and paste this page. Okay. So check this, right? We want to go now, right, from point E to point G, but we don't have a vector along that pink line, not so? So what are some alternative routes? We have two. We could go from E to O and then O to G, or we could go from E to F and then F to G. Now, for the sake of illustration, I'm going to do it both ways, just to show you it doesn't matter which way you go. Right? There's a rule that says the sum of the vectors in a clockwise direction is equal to the sum of the vectors in an anti-clockwise direction. All right, so let's go. Right, so let's go E to O and then O to G. That's the easiest one, right? So this is equal to E, O plus O, G. Okay, now the vector, now the OG is the same OG we used in the previous one. And that's easy, that's just a C, not so? But the EO, this piece here lies on what larger line? It lies on OF, and the vector along OF is D, right? So OE lies along the larger line OF. What fraction of OF is it? As in the orange here, not so? 2/3, right? Now, on top of that, we're not going in this direction. In which direction are we going? The opposite. So we'd have to invert the vector, right? So that's equal to minus OE plus OG. So OE is 2/3 of OF, and OF is just D. This is minus 2/3 D plus C, right? Or you could simply write it as C minus 2/3 D. Right, now, let's try it a different way. Let's say you have E, G, and you wanted to go E to F and then F to G, right? So we have E, F plus F. Now, EF lies on what larger line? It lies on OF, right? What fraction of the whole line is it? EF is 1/3 of OF. Plus FG. Right. Well, at least you know as that and not something else. Anyhow. Sorry. I wasn't supposed to, right? All right, so the whole vector OF is D. So it is our 1/3 of D. And now FG, we found FG in the purple all the way to the left, right? And that's C minus D. So if you shift around your stuff, you have C plus 1/3 D minus D. And 1/3 of D minus a whole of D. 1/3 minus 1 is minus 2/3. As you can see, these two are the same. Sorry. About now? Who's sure now? Okay. Riri. Right. Okay. Google Meet. Right. I should have one. Liam. Oh. Quick G for good day. All right. Okay. Copy and paste this. Last thing I want is OM. Right. The last thing they want is OM. Okay, M is the midpoint of EG. Right? So we talked about that here already. Now, the easiest way to go from O to M is to go from O to E and then E to M. You could also go from O to G and then G to M. Right? You could also go O to F, F to G, and then G to M, but I think that's unnecessary. Right, so OM is equal to, yeah, of course. It's just that you have more steps in the working, which, well, it means you have more possibility for error the more you do, right? Now, OE lies on the larger line, OF. And OE, as you can see in the orange here, is 2/3 of OF. So that's 2/3 of OF. Right? And then EM lies on the larger line, EG. And EM is a half of EG. And we found EG here. Right? So 2/3 OF is simply 2/3 of D. Right? Because OF is D. plus a half of C minus 2/3 of D. So that's equal to 2/3 of D plus, 1 second, right? Plus 1/2 of C, and then a half of 2/3 is 1/3. Ah, right. So the final answer here. So 2/3. So yeah, we could put these C. So 1/2 of C plus 1/3 of D, because 2/3 minus 1/3 is 1/3. Right. Okay. So this one wasn't so bad. Sorry. Okay. So I'll leave it there for a couple of seconds if anybody's copying it now. But we're gonna jump back to question 8. The last piece of question 8. Okay. All right. So we have one more piece to just kind of backtrack here and do the 8B here.
There are ways to do it where you instead of bringing A across, you bring B across and then the X across the other side.
Oh. To bring it across, because with the B,
It just be B in first,
You
but then
could-
how would you get the X?
see, with bringing those across, how do you find the inverse of a 2 by 1 here?
That's true.
Okay, so just backtracking to the last part of question 8 that we didn't do last time, right? So write 4x squared minus 24x plus 31 in the form of a by x plus h squared plus. So this is what? Completing the square. Do you remember your formulas for h and k? So h is simply equal to b over 2a, right? K is a little more involved. It's 4ac minus b squared all over 4a. And then your a, well, so remember, the coefficient of x squared is a, the coefficient of x is b, and c is the constant. All right, plug it up quick now, see what you get. Sorry. Sorry. Sorry.
Oh, arbitrary.
Ah, your girl Deji. All right, let's check it out. Cool. So B minus 24 all over 2 by A is 4. So you have minus 24 over 8, which is minus 3. Right? And for this one now, you have 4 by A by C minus, I'll move that, minus B squared all over 4 by A. Right, we could plug that up in a calculator, why not? Right, so 4 by 31, 496 minus 24 squared. So minus 80 over 16. Yo. All right, cool. When's it then? So minus 5. What we're doing here now is 4 as A. X plus H is X minus 3. X plus H squared minus 5. All right, guys. I'll see you all on Wednesday later. Bye. All right. You're DG. You're good. You should just simplify them all the way. All right, cool. Okay, Google Meet. If you guys are good with that, just kind of give me a quick G. We'll go on to the curve sketch real quick now, right? Let's sketch this. Roots. We are roots, boy. Roots b squared minus 4ac 480 496 5. Yeah. Let's do this piece first. The equation of the axis of symmetry is actually pretty easy, right? That is simply x equal to minus h. H was minus 3, right? So x is equal to minus 3. Therefore, the equation of the axis of symmetry is x equal to 3. Okay, now to sketch the graph, we need a few points. So this point here, first, that is the y-intercept, right? Then we know, by the way, that it's actually a minimum curve. And we know it's a minimum curve because we have a positive coefficient of x squared. And the minimum point, right? So the minimum point is simply given by minus h and k. So minus 3 becomes 3, and then that's minus 5. Okay, so we have that there. We also need roots. But to get the roots in this particular case, we need the formula. All right, let's do the formula. So x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Although I really just feel you could just do this, to be honest. Well, I mean, we'll draw it better than that. So minus b, so that's minus 24 becomes plus 24. So plus and minus the square root of b squared. So that's again minus 24 squared minus 4 by a by c all over 2a. That's 2 by 4, which is 8, right? Okay. So 24 squared is 5. Hold on, let me get a different color for that. That's 576. 576. 625 minus 50. 575 plus back one, right? 576 minus 480, 496. That's 80. All right. So you have 24 plus or minus, and root 80, that's 4 root 5. 80 all over 8. Okay. So we could actually, yeah, we could do this. (24 plus root 80 divided by 8. So about 4.1. And 24 minus root 80 divided by 8. 1.88. 0.9. Okay, cool. This now right, so the curve is not terribly smooth, but we'll so the y-intercept is 31. All right, the smaller of the two roots is 1.9, the larger is 4.1. 1.9 plus 4.1 is 6, and 6 divided by 2 is 3, and that's the equation of the axis of symmetry, right? And yeah, if we drop a blue line, sorry, a line here, right? That's the line, that's the axis of symmetry, where x is equal to 3. Right, so that's 3. Right? The axis of symmetry, the x value is actually the midpoint of the two roots. Right? And then of course you can read across here y, so y is equal to minus 5. There you go. Right. So yeah, so curve sketch. So if anybody needs a refresher on that, I believe we did that back in July, August. So I have this is the Jan 2024. Jan 2024. Yeah. I had some unforeseen expenditure, so tomorrow I'll have cash. All right. So yeah, right, folks. That's about it for the Jan 2024 paper too. Right now, we're just gonna keep going backwards through the 2020s as far as we could go. Right. So on Wednesday, we're gonna be starting May 2023. That might take 3 days again. Now we also not having class on the Monday, unless you all really want to have class. That's a public holiday. So we could have a spiritual short of acceleration day, I believe. Yeah. So we could have, if you all want, early any day, preferably, but we could always discuss that. All right, cool.
Tomorrow.
Yeah, tomorrow. Right. And then as you all know, not long after that, the term ends. Right. We'll keep classes same days, same times. Yeah, later. Yeah. All right, tomorrow. Yeah. Well, yeah. So, but this Monday, of course, it's a public holiday, Easter Monday. So we might just we might push that class to the Friday here. And then when we come back out to the Monday, well, from that Friday we are 2 weeks. So yeah, so we're gonna be binging some POA this week here, and then right after that POA exam, we're binging some maths. Yeah, no problem. All right.
Because my mom thing is like.
Oh, what? The first of April? Oh, is that paper one? Okay, that's it. We could do multiple choice. All right, so Google Meet, that's about it for today. If you guys have any questions you didn't get to ask, please feel free to let me know. Apart from that, have a good evening. See you next time. Bye. All right, later. Okay, cool. Talia, hey Talia. I know seeing you there.